Hi everyone! In this video, we'll be learning about core ways that you can love your computer and server, pun intended. We'll be talking about what are cores, what is a computer processor unit, and we'll be talking about the terminal and htop commands by which you can monitor the health of your computer and all of its allocation of its processes and what is the percent of the core that's utilized, how you can see how burdened your computer is, and how you can give it more love by seeing how the cores are being utilized and monitoring its performance as well. We'll also be looking at the Task Manager and Activity Monitor. So Task Manager on Windows and Activity Monitor on a Mac computer. So that's what we'll be talking about in this video. How you can learn about cores, CPU usage as well, looking at the history, figuring out how your cores are being allocated when you are running different tasks. Because if you can understand what your computer is going through at its core, pun intended on the core, at its very core, if you can start loving your computer from here, you can avoid having your computer die, crash, and be upset. And in the spirit of Valentine's Day, let's just show our love for our computer. Let's understand when it's running processes, what's going on. How is its memory looking? How is its CPU looking? So I'm Saniya and I'll be walking you through this in this video today. And these are really helpful commands that hopefully you'll thank yourselves for watching this video one day. I hope that will be the case. We'll talk about looking at these different cores here and how they're being allocated. So just stay tuned. So I'm going to go over some concepts like the cores of what cores are, and then we'll be doing hands-on with a Mac computer, Windows computer, and a server to help you understand these things visually and also from a command line perspective. What is a CPU? A computer processor unit here. So let's talk about what is a CPU and what a CPU looks like and where it's located. So a modern computer processing unit or CPU is usually small and square, and it has many short rounded metallic connectors on its underside. So if you see over here, you can see that this is sort of like what this chip looks like. But some older CPUs back in the day have pins instead of these metallic connectors. And a major thanks to Livewire as well for this visual and some of the explanations here. So the CPU is able to attach directly to a CPU socket or sometimes a slot on the motherboard here. And the CPU is inserted into the socket pin side down. So even today, and I can attest to you, sometimes it's worth getting a fan because to cool down your computer, because after running even a short while, sometimes modern CPUs can get very hot. So sometimes you can cool down your computer as well. And one thing I learned is please never ever keep your computer on like a case like this, for instance, when it's resting, because there would be no holes for your computer to, and I learned this the hard way, there will be no holes for it to release some of the hot air when it's processing. And it's going to overheat because there's no way for the heat to escape from those vents or those little holes in the computer. There are some vents by which when it's overheating and when it's running, it lets that heat out. And if you place it on a surface, on a cushion, it'll sink in to the shape, and there'll be no way for the heat to escape. So you need to be very careful. So CPU cores, so some devices can have a single core processor, while others, the newer ones tend to have a dual core or quad core processor. So if you run two processor units side by side, then the CPU can manage twice as many instructions every second, which improves your performance. And sometimes some CPUs can virtualize two cores for every one physical core that's available, which is called hyperthreading. So we'll kind of talk a little bit about these, but you can sort of see the improvement from Intel Core i3 to i5 and then i7 as well. So let's talk more about some of the things about what is a computer processor unit. So you probably see this. This used to be back in the bulky computers as well. This used to be like the desktop part. This part is a monitor. This is the main, part. I remember it used to be so big and boxy in old computers that I had. So What is a computer processing unit, a CPU? So a core is also just referred to as a CPU core. So each core is the brain of a CPU here. So we can see if we have a CPU chip here, we could have like a dual core, just two cores here, a quad core, four, one, two, three, four, six core, six of these little rectangles, octa-core, eight of them, multiple cores, so many of these. And we can see like on the memory, we can see all these cores here, as well like an Intel core. And what we can see is that a core is able to receive instructions and then performs calculations or operations based on those instructions. So a computer processing unit can have many cores. So it can run many processes at once easily, which can boost the performance. So it can multitask, it can run many different things at the same time. So it's definitely recommended if you're doing really intense things to get more cores. So it can run many tasks at once, it's faster, and it can run these intensive applications and programs, especially I run them, especially in the biomedical data sciences. And if you have many cores, then you could have multiple processes on one chip. So if you have one core, it's typically called single core. It's typically more old-fashioned, so not the greatest situation. If you have two cores, it's called dual core, four cores, quad core, six cores, hexacore, and eight cores is octa-core. So this is a little bit getting more a little bit technical as well, but I just want to give a little bit of a background. So multi-core processors, as we talked about before, are basically computer processor with two or more separate CPUs or cores. And a single processor is just, a processor that has one CPU and it can only handle one thread at a time. So we're going to talk, what are threads, right? So each CPU can read and execute programs separately, almost like the computer had several processors. So it can take and it can help break down tasks and make them easier to run. So we have programs and applications, and it's the job of the developer, the application and software developer, to make sure that the code can be run in a parallel fashion. In our programming language, for instance, there are many ways to write and parallelize your code. But basically, when we look at a program or application, that's written by a developer, for instance, or even as by any programmer, it produces its threads or strings of data that can go through a processor. And basically, each CPU is able to handle one different thread from the program or application, and it can work on that. So you can have a program, it produces threads, like strings of data, and it goes to a processor, and the processor is going to allocate a different thread to each core, which is also called a CPU. So each CPU will be working on a different thread. So if you have several cores, then at the same time, you'll be having many different threads being run. Each core is handling its own thread, and it makes it faster to do intensive tasks, because each core, again, is handling a different data thread at the same time. So it's like a divide and conquer approach, where you have all these cores here and you give them each one thread of data. But in an extreme situation, then if you have a situation of hyperthreading, then what will happen is that a core can support two threads, which is called hyperthreading. Otherwise, there typically is just one thread for one core. So each core can handle just one thread, one string of the data. So the programmer has to figure out how to break apart the task in the program, because people will and users will complain if it's too slow, for instance. They have to figure out usually how to make the code run faster, how to make it run faster, how to break it apart so that it can run simultaneously on different threads. That could involve, if you have calculations that are being done on a giant matrix, for instance, have it broken apart and sent in small pieces to each core, and then at the end you can just combine them or something like that. So we can see like the threads and the processes here as well, and how the cores are being allocated. And usually it's one core runs one thread, but in the case of hyperthreading, then a core can run two threads. I want to talk to you guys now just with some suggestions of cores that you may need, because we are all so different. Modern computer CPUs, they tend to have between 2 and 64 cores, but most computer processors have 4 to 8 cores. So most times, 2 or 4 cores can be enough for you guys, for your needs. But if you're a video editor, if you're an engineer, data analyst, if you're a STEM, science, technology, engineering, math student, for instance, then 6 or more cores would be great for you guys. So basically, you could just be using it for Tumblr or just some apps or like, uh, Garfield, it reminds me of Yankee a lot. You could just be using it like that, but what's key is that, if you are doing high computations, then 6 or more cores is typically great to have. So computers usually are 2 to 64 cores, but modern computer processors are usually 4 to 8. But I recommend more cores, especially if it's doing high video editing, a lot of frames per second, lots of like intensive work, many programs open, lots of computations, and I do recommend this. But this is not the only solution, otherwise you'll be like me and you could potentially kill your computer by accident. Don't be a murderer. It's bad. So we can also look at servers. And servers are basically like they're these dedicated um, warriors in a way. They're just dedicated soldiers that are powering through to help you run your tasks with high performance. And as we've seen, there's so much that goes behind memory management and database management systems and swap and memory. It's really complex, and there are a lot of classes and other things you could learn more about this on. I remember it's kind of a little bit complex too as well, but it's super important. How do you allocate this type of data? And as you can see, we, on Magic School Bus, I grew up watching this. It's very cute. You can basically see that different students have different needs, and this teacher is going through and taking the students on a nice adventure as well. So this teacher's requirements would be pretty different than our requirements, taking them on field trips. So Valerie Frizzle is her name here, or their name, but basically she takes the students on lots of field trips and have them explore. So her needs to be different from a typical teacher's, right? So the idea is that what you need for your core, at the core, kind of really is based on what you're doing. But these are some recommendations. So I hope these can help you when you're selecting a computer. I highly recommend trying to get this CPU, trying to get as much computer processing unit ability as possible. So this is an example of a server, so multi-core processes, they can produce high performance computing. So especially like with me, I run code that can take days, hours to run. It could take a long time. I used to think people were exaggerating when they said that code can take a long time, make sure it's efficient, but I've actually seen that happen. So like these are servers here. You can see what they look like. Multiple people are trying to, this is like a web server here, but these are physical servers as well. So you could also have web server storage or physical servers as well here. And for my computer, I often show you guys on Putty that this is like what I've used to log in. There's also VS Code, or you can just do secure shell SSH, and I showed this in other videos. But what I try to do is I try to log in like to Nebula Line, for instance, which will give me access to these powerful biomedical informatics computing shells here, which I can use, these servers that are powerful. And you can see like kind of what they look like. So they're definitely like on steroids. They can be way more powerful than our own computers are. These are like supercomputers as well. So just, you can take some of the computational burden off of your computer and run them on a server. And that's why I kind of talk about how you can do that, how you can get up and running. And I kind of show some things in this video too, how you can monitor how much usage you're using, because many people would potentially be running their code and their processes on these servers. They're kind of like outsourcing all their heavy computation on that. My brother keeps on telling me repeatedly, love your computer as well, put things on the server. I have videos on that to help you guys. So I want you guys to love, 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 love your computer. We're going to be learning all these commands just to help you love and spread the love for your computer as well, because computers do so much to help us out. And you can see here, this guy's happy with it, and his partner is not too happy that the computer's right there. You could be wrapped around your computer all the time like me. You can love your computer. It's pretty much how I spend Valentine's Day, behind the computer. So all my friends are in there. I love my computer. I see loving your computer. It's a real thing. But don't be like Garfield. Don't be like him. He says, I love my computer, and then he's like, ripping it to shreds. He's really grilling it, and his computer's gonna die. So in this video, I want to talk about ways to ensure your computer and server is not too overwhelmed. Love is kindness, so please be kind to your computer. Please monitor its health, its memory allocation, how it's doing, its performance. Make sure that tasks of yours are running, and shut down the tasks that aren't, are taking up too much, or even just have them on a server, and then monitor the health of on the server to make sure you're being considerate to others there too. So this is what we'll talk about in this video. I'll be talking to you about htop in how do you run it on a command line, and then about Activity Monitor on a Mac, and about the Task Manager on a Windows, and then also about the server and how you can, when you're logging into a server, how you can secure shell into other different servers, check memory allocation there, what's available, how much you run as well using htop, because command line is kind of like allowing you to interact with servers in a way with different computers. And I show you visually kind of what memory management looks like on a computer through nice little GUIs, graphical user interfaces, like Task Manager, Activity Monitor. And I also show how it also looks in a command line on your own computer, and then also on a server, so that this will make more sense to you guys as well. So again, a core is a CPU core, computer processing core. Again, please subscribe.
Hi everyone, I am Saniya and in this video, it is Valentine's Day. Happy Valentine's Day. So I want to show you a very cute and cool tool to use to better understand what your computer is doing or what is happening on a server. So if you love your computer, then you'll be able to check up on its health and see how all the cores are being used up, see if it's getting really worked up, how you can allocate resources, not just on your computer, but also on a server. So you can better figure that out. So I want to show you a really cool command that is called htop. And you can see on my top, there's like this nice little rose that's following me around. But that's the key idea. We're gonna see htop, top of the head, so to speak. So it's also kind of themed for Valentine's Day. And you can see all these little teddies here. So I'm going to show you htop, but I'm also going to give you a conceptual idea. And this is something that really helped me. So I just learned about this. I want to share it with you guys too, so that it can help you. So basically on a computer, and I'll show this to you guys in R, for instance. We're going to figure this out in other ways too. But in R, there's a package that's called Parallel. And if you don't have it, you can install it using install packages .parallel. And I talk in other videos about installing packages, but we can even see for Parallel, for instance, support for parallel computation in R, this package. So either I can just do library, I already have it installed on my computer, but if I didn't, I could just do this. And when I load in, and you could just watch this part again. And when I do the parallel part, it's just gonna look like this part, and then you can see now it's got selected. So, and if I deselect it, it would just be like detach. Detach gets rid of a package. And so I'm just going to select it again. So then they have this function called detectCores. So you can just run this and it'll allow you to detect the cores. So I have 12 cores on my computer. So 12 cores, kind of really nice, right? So that is something we can do to check all the cores. So that's something that could be very helpful. So that's something that could be helpful if you want to figure out how many cores do you have on your computer. But I also want to show you that but I also want to show you how you can do these things using the terminal as well. So one of the things, if you're able to, if you can go here to your terminal. So what I did here is I just kind of oh gosh, I went to terminal here. So here I am in the terminal. And now one of the things that I want to show you. So we're here in the terminal. And you can see that it is Valentine's Day indeed. So on my computer, I can do this command called htop. So what htop is going to help me see on the terminal. So I went to the terminal as well. You see this terminal, sorry. You see this terminal, you see this terminal here? That's where I came. And I just typed in, htop. So let me just sort of write it, htop. Okay, so I went and I typed in htop here. That's what I typed in, htop. Now, if I want to leave this, I just have to write this command. If I want to exit the scenario, I just have to type in Control C, and that will exit this. So I typed in htop to get here. And now if I type Control C, it's going to allow me to just kind of quit out of here. So let me just, quit out of here, pressing Control C. So again, I can press the up arrow and I can see htop. So now you might see this and you might be wondering, okay, well, what is exactly going on here? You see a lot of different processes, like, there's this Brave browser app, for instance, or my brother is telling me to install. You see a lot of different things being run right now. If I want to, you see some of these things are typically being done by me, Saniya Kola. It's abbreviation for, for Saniya Kola, is short for my name. But you can see that some processes are by me and other processes could be by the computer. So I can just, leave this for now. And if I do htop/u and then I do Saniya Kola. I have to make sure that I get the username right. So all I have to do is do htop/u Saniya Kola. And this is kind of short for this, so it's my full name is my username as well. If I say htop, it will show me everything, all processes. If I do htop/u and then username, it will show me all processes being done by username. That's what it's going to show me. So what you will probably see right now is that in particular, since we did htop/u and then we did Saniya Kola, it's supposed to be Saniya Kola, you can see that all of these users here are me. And we can just see the processes that I'm running on the computer.
Let's just go back.
This is what I done here, htop/u Saniya Kola, htop/u Saniya Kola. It shows all processes run by username Saniya Kola. So this is me running those processes. Whereas htop just shows all processes being run on this computer or a server, for instance. It really depends because you can use this on either. So if we just use htop by itself, this top one, it shows all the processes that are being run on the computer/server. And if I look this up, it's a way of like shaming you, how much are you running in particular? How much space are you taking up? So let's kind of focus on this htop right now, but you should definitely monitor how much you're using up. So if we look at htop, for instance, then the interesting thing is you can see again, it shows root. So some of these are like the computer's been doing some like open directories and doing other things, and some processes I'm running. And if this was like a server, we would see lots of other people and what they're running too. So we could figure out maybe who's clogging the server as well. And we can see the uptime for this computer, how much time it's been up for, the load average, how many tasks are currently running. And do you remember how I showed you that we detected that I had 12 cores on this computer? And it really depends. So, I loaded in library parallel. If you don't have it, you can install packages and then you can detect cores. So that's like one really quick way to detect cores. So I have 12 cores and the numbering here is from 0 all the way to 11. So this kind of shows you the health and stamina of 12 cores on my computer. That's what it's showing you, like how they're being used. That's what this part is showing you. These are the 12 cores that I have. This memory here, and then we're seeing the swap. So if the swap is high, then there are lots of computations that are being done that are kind of like, memories being kind of reorganized and reshuffled. So we really don't want this to be too high on the scale from here to here. And this is showing how much of the memory is being used. So out of this 32 GB RAM, so this typically has to do with the RAM that you have, your RAM, 32 gigabyte RAM here. If you see based on your RAM, how much is being utilized out of the 32 GB, RAM, random access memory, I'm utilizing around 11.2 gigabytes of RAM. And then because I have 12 cores, we can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 12 because it's 0 to 11. These are the 12 cores basically. This is how much my RAM is being used. If the swap gets too high, then that's pretty bad. So these are some commands that you can see as well. And you can run these on Linux terminals as well, even in Ubuntu, and I have videos talking about that. But I want to show you exactly kind of what this means. If you were to view it visually, like if you were to view the health of your computer, sometimes I do check Task Manager a lot. And if you see here, there's something here that's called the Activity Monitor. So we can come to the Activity Monitor here. And it shows you all the things that you're running here and how much memory, how many threads, what are the process IDs that you're running, and these process IDs, they're kind of reminiscent to like these PIDs, these process IDs. So we can kind of already get some idea from here about some of these processes that I'm running as well. What ports am I using? Virtual memory. I can even like sort on like which ones are more memory intensive, for instance. So this Zoom is taking up a lot of memory right now, for instance. So these are all things. I can look at memory pressure, physical memory. I have 32 GB. How much memory is currently being used? How much swap is being used? How many gigabytes of swap? And I see that I have 32 GB. And out of that, how much memory is being used, how much swap, how much is cached, app memory, wired memory, compressed. So these should typically map to each other. There might be a little bit of a lag. But in any case, we can see that there's 1.18 to show you that they kind of map to each other. Maybe just some slight differences you might notice, but that's kind of like no big deal right now, as of now. But we see that the swap used is 1.18 gigabytes. It's kind of like this. The same thing here for the swap. SWP is short for swap. So it's the same thing that you can see here as well. App memory, physical memory, this 32 GB I can see here as well. And there are other windows that you can see. If I go to Activity Monitor and I check Windows, I can see my CPU usage. So what this is showing me, in other terms, this is showing me how much of my processing unit I'm using. So this is showing each of my cores. I have these 12 cores again, 0 to 11, these are 12 cores. So it's kind of showing me how much is being used right now of each of these cores. So this is like, we can kind of already see these cores. 0 maps to this one, 1 maps to this one, and you can see that relative, this one is not being as used as much as this one. So if we were to compare these, for instance, what we would see is that this one is being utilized far more. This guy over here also looks a lot taller in terms of how much is being used. Like the taller it is, the more it's being utilized. And for instance, this guy here is much smaller, for one here. And indeed, like if we see what this guy looks like, it's kind of not as high. So we're not really using as much processing on core number 1. And core 0 is using way more than that. We can see Yet core 4 also seems a bit occupied as well. So like 0, 2 is kind of, you can see how this changes, and then you can kind of see on this scale from here to here, it's sort of like 49.3%. The htop is almost giving you more metrics in a way to some extent than what you can see over here. It's exactly telling you how many, what percent of the core is being utilized right now, which is kind of key. So we can see, for instance, that number 11, the last core, is not used as much. Number 10 is kind of high up there. So we can see how the cores are being utilized. And that's what we get from Activity Monitor by looking here at this CPU usage. That's what it's showing us here. The other thing I can do is I can also look at CPU history. And this right here is our CPU history that you can see here. So since the moment I open up this CPU history, it's going to start collecting this data basically, which is essentially what this green and red is doing, but it's measuring this now over the time point. So it's like at each time point, it's capturing this green bar information and this red bar information as well. And it's helping me in this process because it's capturing the height of the green corresponds to these heights and the heights of the red. So here they happen to call it core 1 is just core 0 here. So the numbering might be just a bit off. You just have to keep track and just make sure that you're consistent with the numbers. So here this represents core 1 here. And then this other one, let me take the orange. This one right here would just be like core 2. And we can already see that, this core 0 here, which is a core 1, is kind of being utilized quite a bit. And we're tracking at each time point. So on this axis, this is essentially the time. That's the time for each of these cores. So these 12 cores, this is what it is. So this 11th one right here would be maybe this core 12 right now. So it's not being utilized too much, thankfully. So it's just been like really, really tiny. So you can see that out of this whole window, and this is over time. It's being filled up each second. And the height represents the amount that's being utilized, the percent of core utilized. That's what the height is representing, for each of these cores. And that's, again, kind of similar to what each of these is showing, like, 42.7%, then, the ratios of this green to the red. That means that we are filling up, for core 6, which again, here would be core 7, then we're filling around like 45% of this here. The height, the bigger the height, the more is being utilized. So if I'm running really intense programs, I would expect that quite the huge height of this would be filled by many of my cores. Parallel processing allows me to distribute this across many cores, but I can kind of see the same information that I can view in htop. I can see it real time, using the history of the CPU usage. So it's basically this information, this dashboard here is captured in the CPU usage with less information. It's the CPU usage doesn't really show metrics as much. That htop shows you way more metrics. And in addition, this information from htop at each time point can be used in the CPU history to plot the performance of each of these cores, of each of these values, each of these percentages are used to plot over time. Like each of the, this line to this line to this line, they represent different time points. Just since you open up CPU history. So it's a way for you to track how well is it performing, how many cores, what is, what's been utilized right now. So we can see that this is stabilizing a bit. We can see that this has been pretty low, that this one was dropping in this core 11, which is corresponding to core 10, that this one was dropping here, then it increased. So that gives us more metrics on the health of it. And lastly, we can also just check out our, a graphical processor unit as well. We can just track the history of it and how it's being utilized. So this way you can figure out which cores of yours are being kind of taking up are really suffering, really need to be freed up, or how they're being overwhelmed. You can also kill certain processes that are taking a long time as well. So, or that are taking up a lot of your computer. So I'm going to close these all out here, but we can see certain process IDs, and you can kill them here in the terminal too, using this F9 command as well. You can kill some of those. You can see the time that the processes have been running. Take it with a grain of salt, the memory, CPU usage as well. And you can track this over time. It might be refreshed here, so that's pretty nice. You just always want to make sure that you're monitoring the performance of your computer and which cores are being allocated. Like it seems like core 2, which is core 1 here. These numbers are 1 to 12, but these are from 0 to 11. You just have to keep it straight. And then you could always see like, which processes are taking up more time, what is the swap, how much is compressed. And this way you can better take care of your computer and not have it be overwhelmed. You can see what is being used and who's using what. So I hope that this will be helpful for you guys. So please let me know what I can do to help as well. So, htop to the rescue. And this will allow you to work with people as well on servers and figure out how to allocate resources effectively. I'm Saniya Kuller, and I hope that this allowed you to visually also understand kind of what htop means as well and get that intuition so that you can see on a computer how there are other ways for you to monitor the health of your computer, but how Linux commands, which is also you can access in Ubuntu, and in general, you can view the health of your computer doing this. So I also want to show you why it is also important that we have Ubuntu Emulator on a Windows computer. On a Mac, you can look at the terminal and run htop to see the health of your computer just by the default terminal. And on a Linux computer, you of course have the Ubuntu and you can run all those commands from the get-go. But on a Windows computer, it's a little bit trickier. You go to your terminal, for instance. I come here and I go to the terminal, which is also called the PowerShell. And if I just go htop, it's going to say the term htop is not recognized as a name of a commandlet, function, script file, or operable program. Check the spelling of the name or if a path was included. So basically, it just doesn't know what this htop means. But luckily, I have the Ubuntu Emulator installed, Windows Subsystem for Linux. So this is so helpful for me. And I have videos on how to install that on a Windows for free. So please do subscribe, please do check that out and then reach out if you have any questions at all. So you can definitely install this Ubuntu Windows Subsystem for Linux emulator and utilize that. So if I instead went here, if I click this Ubuntu here, again, that's just from this Ubuntu, then I can just do htop. So htop will show me different things. So this is on a Windows computer using Ubuntu here. That's the application that we're using, the Ubuntu emulator. I can see here how many of the cores are being utilized. So here now there's 16 cores here. If I did library parallel here, on the console, and then I just did detectCores, it would say 16 here. So this 16 again now it's more than on the Mac computer. So this one would just show that, okay, well, the 16 cores here represents these 16 cores here. And in the Ubuntu version here, the numberings are 1 to 16 instead of 0 to like 15, for instance, as it was on the Mac. Now it's 1 to 16. So I have 16 cores here. So there's 16 cores, which is great. We can utilize those 16 cores here. And we can see these with htop, and I can see root and Saniya and all of those things there. And basically, if I want to, exit out, I can do Control-C. And if I did htop/u and my username is called Saniya here, I can then see all the things I'm doing versus what the computer alone is doing. Like, what part am I responsible for? And you see that even me running htop/u/Saniya involves some little bit of overhead for the computer, that you can access a task manager using ctrl-alt-delete, for instance. I use the task manager all the time using this Windows Subsystem for Linux Ubuntu Emulator can show you a little bit more metrics. Like you can see how much of your memory is being utilized by certain apps as well if you check your task manager. You can now see on another day what my task manager would look like, for instance. So it's got quite a lot of applications open as well. So this is the processes tab. We can also equivalently look at the performance tab as well. So it shows us the CPU usage as well over time. We can track the activity. We can also look at the memories. Since I've had this task manager open for quite some time, it's already showing over time as well. What is the percent of utilization of my cores? I can see like the graphical processor unit as well, the disk, how much is being used, memory as well, how much is being used. So out of around 60 4 gigabytes, I've already used like 38 and I have 25 roughly available. So this just shows me another way to track the metrics. So it's kind of similar to your activity monitor, but this is just kind of like another way to just gauge the health of your computer. There are a few other options here, like app history and startup, and it does also kind of show you, the time it's been up for. And now we can also just see htop, what parts are applicable to us. And if we just run htop here, so this is the command where I'm just running htop, and it's showing me everything, including root and Saniya here, because on a personal computer, and then this is you, and then this is Saniya, where I'm just seeing is processes that are run by this user named Saniya. So I'm filtering on user being Saniya. So I'm going here and I'm only looking for the ones done by Saniya here, and that's what this shows me. What are all the things that are being run by Saniya? I mean, there's a little bit of a lag, but in typical, if we just see htop/u.asaniya, my name, we would expect less of the cores overall, like if the metrics to be kind of not as bad as htop, because htop is Saniya and root, so it's running additional processes. So we expect the usage, like, again, this percentage is the percent that is being used. That's what the percent is referred to, the percent of the core being used. That's what it's saying, like how much percent, like 41% is being used as well. And out of the 64 gigabyte RAM here, 44 gigabytes are being used out of the 64 GB RAM. You can see the RAM, you can see the swap as well. So this gives you a lot of insights as well. And indeed, if I also show you, like on a remote session as well, we can remote in and see. And why this is helpful is, like, let's say, I'm just going to log into my account here. We can see how different computers have different memory requirements. If I do htop, I can see that this is a really bad situation here. This is me, what I'm running in this htop command, but people are really running out of 126 gigabytes of memory. All the swap is being used. This computer is so stressed as well. Let me log into a bigger server, for instance, and then show you htop now. So this has 756 gigabytes of memory. That's a lot of memory. And it has 64 cores, from 1 to 64, so many cores. The swap is about 5.52 out of 12. We can see, like, I was just running this over here, but people are running all sorts of commands. So you can see how much a given person is running, but they're still using up a lot. And the uptime, how much time the server has been up for, touch wood. And then you can see many different users here. We can also SSH into Mastodon too. We might want to run processes on a computer or server that is not so busy or so stressed out. Like this computer is so stressed, and we can see so many different users here, like Condor, and there's me here. You can see a lot of these commands here. So I can just see how much am I running. And I can type in htop/u and then putter, and this will show me all the things that I'm doing and how they're being allocated. Like, so I'm using up one core completely here. I kind of showed you again using a Mac computer, what it looks like to use
cores, how would this swap and memory and this core, how you can actually kind of see that real time, even if we don't use a terminal. To interpret what these colors mean when you're looking in htop, for instance. So if we don't understand what these colors mean, what we could do is we can see here that there's a button that we can press, and this can also depend on our default settings. But if we press F1, we can get help, and F2 is for setup, so that we can change these colors. Because right now, I like these. These look like, Christmas trees, green and red. So I'm happy about that. I'm a huge Christmas fan. But the idea here is that, if you want to get help, you just have to click F1. So just F1, and it's going to help us understand basically what these different colors here mean in terms of memory and swap, like what these mean. So I'm going to hit F1. Okay, function F1. So for CPU usage bar, when it's looking at the CPU usage bar, then let me just take a little screenshot of this then to help us understand this. If you see some status that has R under here, R means something is running. R is for running. S is for sleeping. So under status, S for status, that is one thing that we see, that this will show us what is running here. Status, R is for running, S is for sleeping, T is for traced and stopped, Z is for zombie, D is for disk sleep. So this kind of are the different kinds of commands you could see for the status. Then for the CPU usage, this is showing you the used percentage. So out of all that is available, computer processing units for all these cores here, like these 16 cores, how much have I used? That again is what these percentage values are meaning here. And, blue means it's low priority. If something is blue, like for instance, like this could be like, low priority, but there's no blue here. I mainly have normal, which is in green, and then red is kernel. And then this light blue just means virtual IZ. So for the memory bar, green is how much I've used. Blue is the buffer, and this yellow here is the orange is the cache out of all the memory, out of all this RAM. Again, this is the RAM. The RAM is this memory that we have on our computer. How much memory, that's the RAM. And for the swap, the red is basically how much we've used about it. And these are some other metrics that we can see as well. But htop was developed and maintained from 2004 to 2019 by Hisham Muhammad. So, you can kill processes or tag processes using F9. You can set CPU affinity. You can show processes of a single user again by doing htop/u and then writing the username. So these are all these things that you can do, and that's sort of what it means. So for the memory bar, this is how much is used. Green is a normal and red is kernel again. So these are, any way for you to interpret this. And if you want to, you can just kind of set the colors, using F2. You can click this and set your values. And if you don't want to do anything, you can just do F10. And you can just exit out of that. So that's kind of like what those colors are meaning when you see the swap wise. So I hope that that visual example of what your cores are doing, what your computer is actually doing, I hope that it can help you be kinder, be nicer, and just love your computer in general. Just love it, love it, love it. On the spirit of Valentine's Day, the little heart. So love your computer, love everything about it. So hoping everything works out for you guys. So I'm Saniya, and I hope this video was helpful. So if this video was helpful, then please let me know. Thank you guys.
can spread this love by subscribing, sharing, and just looking after your computer and loving and cherishing it. Your computer, your server, just cherish them all. Thank you guys and have a lovely, lovely day. Thank you.